This is 11.6c. We're going to talk about polynomial equations and how to graph to approximate solutions. In the last video, 11.6b, we talked about making a table of values by using synthetic division. And there's 14 previous videos for this chapter now, and you can go to them by clicking the description. Whenever we find the roots of zeros of a function p of x, we've solved the equation p of x equals 0. And one way to find approximate solutions of polynomial equations is by graphing. We graph the function y equals p of x and look for where the graph crosses the x-axis. And we can approximate roots more precisely by further calculation. So we can use a regular calculator, or we could do it by graphing with a computer or scientific calculator. Now, if you haven't seen video 11.6b, you need to stop and watch it now because you're going to possibly get very confused, all right? And the link is in this description, 11.6b, okay? 11.6b. We can use a calculator, just a regular calculator, to find a closer approximation of the root of p of x equals 2x to the third minus x plus 2. It's going to be near a negative 1.1. Now this is the same polynomial we used in the last video, all right? So we've got the same table of values. And using the table of values from that previous video, this is what we had, and we can see when we're at negative 1 here, the p of x is at 1. So p of negative 1 is 1. And p of negative 2 is negative 12. So there must be a root between negative 1 and negative 2 because that's such a large difference, isn't it? Going from a positive 1 to a negative 12. And to get a better approximation, we use synthetic division. And what's going to happen is this is going to be the divisor in our synthetic division, and that's going to be our remainder. All right? We talked about a little bit about this in the last video, so we're going to do it a little more detail now. So just using a regular calculator, you don't need a scientific calculator for this. You could, but we're just going to use a regular one, okay? So we've got our polynomial p of x equals 2x to the third minus x plus 2. And we can see that there's no x squared. So we're going to have to put a 0 as a placeholder for that term. Here's our negative 1.1. And we're trying to find between a negative 1 and a negative 2. So I'm going to try a negative 1.1. I'm going to get really precise here. We drop down our 2. We multiply these and get a negative 2.2. We add it to the 0 and it stays the same. We multiply the negative 2.2 by the negative 1.1 and get a positive 2.42. We add it to the negative 1 and get a 1.42. Multiply it again to this guy and we get a negative 1.562. We add it to that 2 and get a 0.438. So we can say p of negative 1.1 is approximately 0.44, all right? We can shorten it a little bit, all right? So now let's try negative 1.2. We write our coefficients and our 0 to take the place of the x squared, all right, that was missing. And we do our synthetic division, and once we get through it all with our multiplying, adding, we find out that p of negative 1.2 is approximately negative 0.26. See? So we rounded it to negative 0.26. And this tells us the graph crosses the x-axis between negative 1.1 and negative 1.2. We're getting really close to 0, aren't we? So this was a positive 0.44, and that's a negative 0.26. So it has to cross x somewhere between these two numbers. And we can further calculate to try to be more precise. So let's try negative 1.16. See if that can get us to a 0. Well, we're getting close. It's approximately 0.04. So let's try negative 1.17. We do our synthetic division. So we went from a positive 0.04, 4/100ths, to a negative 3/100ths. Well, that tells me now that it's somewhere in between a negative 1.16 and a negative 1.17. So we could continue to try to get it as close to 0 as possible, but that's pretty close. So we have a root between negative 1.16 and negative 1.17. And we have an approximation to the hundredths. So I'd say it's about negative 1.17, all right? So, because that was 0.03 is closer than negative 0.03 is closer than 0.04, isn't it? And if we graph this, the shape of our graph is going to be approximately like this because it's a cubic, because it was to the third degree here, so we have a cubic polynomial function, and it's going to hit the x-axis at approximately negative 1.17. See? In the last video, the graph looked like this, but we didn't have the details of the yellow area, so we got very precise with tiny numbers, and it would approximately look like that, all right? And our next video it's Algebra 2. That's the videos that I'm making for Chapter 11, Lesson 7, 11.7, and it's going to be a word problem strategy of working backwards, but it's good for anybody. It doesn't have to just be Algebra 2. In the previous videos that help us, there's 14 of them. You really need to watch the last 5 or 6 or so if you're confused, all right? Or watch the entire chapter, all the 11s. I'm going to add this to the Algebra 2 playlist, and as soon as we do that word problem strategy video of 11.7, we're going to be into Chapter 12, and we're going to start talking about logs and logarithms, okay? I hope you're having a great day. Don't forget to support me on Patreon.com if you believe in what I'm doing and you'd like to help. I've got YouTube fan funding on my homepage. I've got Patreon.com/JoAnn School. You can even read a little bio about me there. I even have PayPal. All right? I'll see you next video. Bye.